Hello from Chem Help ASAP. In this video, we'll try to provide more clarity around the strength of hydrogen bonding in a drug-target complex. Hydrogen bonds, what are they? They are the interaction of an OH or NH bond with the lone pair of another oxygen or nitrogen atom. This is an actual bonding interaction. Ideally, the donor atom, oxygen or nitrogen, the hydrogen, and the acceptor atom, oxygen or nitrogen, should be aligned as much as possible to give the best bonding interaction. A 180-degree orientation is the best. If you look up the energy of a hydrogen bond, you will find values reported as high as about 9 kcal per mole. That is up to 35 or 40 kilojoules per mole if you prefer those units. In drug discovery, however, the energy of a hydrogen bond will rarely be above 4 kcal per mole, and that would be a very strong hydrogen bond. Why don't these numbers agree? Why would the strength of a hydrogen bond in general be different from one reported in drug discovery? Let's see what's going on here. On the screen is a simple depiction of drug-target binding. On the left is the drug-target complex. Featured in this complex is the target serving as a hydrogen bond donor through this OH group binding to the drug as the hydrogen bond acceptor. Let's assume that this hydrogen bond is the only drug-target interaction. Dissociation of the complex requires breaking the hydrogen bond. In theory, we could use the Kd value, the dissociation equilibrium constant, and determine delta G. What is this delta G? It is the free energy difference between the products and starting materials. Note that the products also include a hydrogen bond, one between the drug and available water. So delta G is not simply the energy for breaking the drug-target hydrogen bond, but also reflects the making of the drug-water hydrogen bond. Why would these hydrogen bonds be different? I mean, we break one and make another. Shouldn't the net change be zero? Maybe not. The hydrogen bond on the left is sometimes stronger because of the rigid orientation of the hydrogen bond donor. Maybe not. The hydrogen bond on the left is sometimes stronger because of the rigid orientation of the hydrogen bond donor and acceptor in the complex. If the key atoms are well aligned, then the net benefit of the hydrogen bond in the drug-target complex will be greater than the hydrogen bond on the right. When people report a drug-target hydrogen bond as 1 to 4 kcal per mole, they are saying that the hydrogen bond in the complex is stronger than any subsequent drug-water hydrogen bonds by 1 to 4 kcal per mole. In contrast, if you Google the strength of a hydrogen bond, that value represents the breaking energy only, not a net change, and the net change is more relevant for drug-target binding. The difference is subtle but important. As Paul Harvey would say, that's the rest of the story on hydrogen bond energies. If you have any questions, they are welcome in the comments section below the video. Take care.